Welcome to the Let's Talk Health and Care podcast series brought to you by the Integrated Care Academy at UE Bristol. We'll be diving deep into exciting research and service changes by speaking to the people directly behind them. I'm Peter Brindle. I'm a GP with a real passion for service improvement, health tech and innovation.
And I'm Mark Griffiths, Pro Vice Chancellor and sponsor for the Integrated Care Academy at UE Bristol. Welcome to Let's Talk Health and Care.
Hello, and thank you for joining us. Imagine struggling with every bite and sip, a challenge faced by millions of people in the UK. Dysphagia, the medical term for swallowing difficulties, silently afflicts about 1 in 4 of the general population, with rates rising up to about 27% amongst those over 76. And for individuals with dementia, the figures are even more alarming, with prevalence rates as high as 93%. This condition not only robs people of the simple joy of eating, it can lead to social isolation, anxiety and depression, and mealtimes, which are often social events, can become really stressful and less enjoyable. And even worse, dysphagia can pose significant risks of malnutrition and respiratory infections, and because of those, even a risk of death.
While traditional solutions have meant relegating people to a lifetime of pureed foods that often look and feel more like baby food than adult meals and often taste worse, there's a revolution happening at the intersection of healthcare and technology. In today's podcast, we explore the revolutionary potential of 3D printed food. And I'm delighted today, along with Peter, to welcome Associate Professor Alexandros Stratakos, who is an Associate Professor in Sustainable Agri-Food Production. And together we will delve into how this innovation could bring taste, variety and safety back to the table for those living with dysphagia. Alex, thank you so much for joining us today.
Thank you. It's a real pleasure to be here.
Okay, well, let's get going then, shall we? What initially sparked your interest in researching dysphagia and the potential of 3D printed food to address this condition?
I'm an academic, a researcher, so all the projects I'm working on are linked to, scientific curiosity. So I'm always driven by scientific curiosity and the potential that our discoveries can help people in real life environments, in real life conditions. But for this specific project, there is a personal element as well. A very close family member suffers from MS, and unfortunately this condition has caused him to suffer from dysphagia as well. So over the years, I've seen how this condition, dysphagia, can affect every aspect of this person's life, not just in terms of meeting his nutrition requirements, but also his quality of life. So this was an extra motivation for me to work on this type of issue.
So it's a pretty personal connection then in terms of this work, Alex, as you've outlined, and I'm sure that resonates with lots of people and their families throughout the world in terms of this debilitating condition that some patients have. Can you share a bit more about your academic and professional journey here at UE Bristol and what led you to this innovative project? Because we've had talks before and I've been completely just amazed by this journey that you've been on over the last several years.
Thank you for your kind words, Mark. I've been very lucky in my academic and professional journey. I got the chance to study in the UK and abroad as well. So I got the chance to work in the UK and different other countries, Greece, Italy, Ireland, and worked in the public sector, the industry, the European Commission. And in all cases, my work, one way or the other, was linked to food and health. And what stood out to me is that how food can influence health, but also the economy, but also public policy. And also the huge potential for innovation in this field, in the food and health field. Not just a possibility, but also as a necessity. All this have led me to do, quite a few years ago, a PhD in Queen's University, Belfast, on food science and technology. And from that point onwards, I have been trying to bridge the gap between science, between industry and consumer needs. And I believe it's very important to try to translate scientific discoveries to real-life applications. So in many ways, this specific project brings everything I've learned about science, about collaboration, about food as a tool for health and innovation together.
Sounds fantastic. Sounds great.
And of course, before I started to prepare for this podcast, I'd never even heard of 3D printing of food. It almost sounds like a kind of science fiction thing that you see in Star Trek or whatever. And I suspect most of our listeners wouldn't have heard of it either. I don't think I'm extraordinary in that case. Do you think you could just talk us through, like in a real layman's guide, what is the process involved in 3D printing of food? Just keep it simple for us.
Sure. Very happy to do that. This is a question we do get quite often. So the first thing we need to do is design a food product that targets a specific segment of the population. Are we targeting elderly? Are we targeting young adults, children? And we do that by working with clinical nutritionists. So after we have that in mind, the next step is to prepare what we call the food ink. This is where a lot of science, a lot of research and development goes in. So the first thing to do when we're developing the food ink is to take native food products, so real food. And at this stage, it's important to remember that this food cannot be consumed safely by people with dysphagia. After we have the food, the simplest way to put it is to blenderize it. But again, at this stage, it's not safe for consumption. The next stage is to incorporate in the food something we call food hydrocolloids. These are additives of natural origin, so natural products, nothing artificial here, that act as gelling agents and thickening agents. So in simple words, they allow us to create new networks within the food, new molecular networks that bind the proteins, that bind the carbohydrates, the fats, antioxidants, whatever it is in the food, and give the food now, the food ink, the textural properties and the rheological properties, as we call them, to make it safe for consumption. After we do that, and that's a very difficult thing to do, we have our food ink. So the next step after that is to design a model of the food that we want the printer to print. This shape can be a steak or something else that looks familiar or something that the person would feel comfortable eating. We design that using specialized software, and this is what gives the printer the guidelines, the instructions of what to print. And as a final step, we take the food ink, we put it in cartridges in the printer, and then the printer, following the guides we gave in based on this 3D model, it prints the food under specific conditions, 3D printing speed, printing temperature, that we have identified previously after doing trials. So this is the process in a nutshell.
So does it actually look like real food?
It does, yes, it does.
Wow. I'd love to see this in action. Probably not ideal for a podcast, but maybe a video version. It'd be great to see in action.
There is a video that we have on the UE website, which I'm sure we'll put in the link for the listeners, which basically brings in terms of visually what Alex is describing for our listeners, and we'll put that in the link because it's such a powerful video, and when you see it happen, you just begin to understand Alex has done a great job there of kind of like describing it, but actually the complexity of what needs to happen to make sure from a quality perspective, from a safety perspective, from an acceptability and tolerance perspective, and just the group of people that Alex works with and are leading, and this goes right through to PhD students as well. There's a whole network of people that Alex is leading and working with here. It's not a one-person industry. It pretty much is a network of people.
And how do you make sure that it's nutritious? So we've established it's going to look great, it's going to be the right temperature. Can you make it like hyper nutritious? Can you make it like, superfood or something like that?
We have the capacity, yes, to adjust the nutrient content of the food, and this is one of the advantages of this technology, of this approach we are creating. So in terms of ensuring that the food is nutritious, obviously we have the right background. Personally, I'm a food scientist, but also we work with clinical nutritionists to make sure the food we produce has the right nutrient profile for the specific group of people. This is how we ensure nutrient content, but also it's very important to ensure the safety of the food itself. Because, as we said, it's people with dysphagia, it's very difficult for them to eat food products that the rest of us can eat. And we ensure safety in two ways. First one, by utilizing high-tech instrumentation that we have in the lab, rheometers, texture analyzers, that can give us a full characterization of the food ink and its properties. And the other way is by following the IDDSI, which is a globally standardized framework that describes the characteristics of food designed for people with dysphagia. So we have this two-way approach to make sure the food is safe.
So not only does it have great nutrition, and it's the right temperature, it looks great and tastes great. It sounds a whole lot better than my cooking, which probably doesn't tick many of those boxes. So I'd love a little box like that in my kitchen, and that on my cooking night, that would be perfect. A great improvement to what I currently serve.
Before we go on to the kind of question of the transformation for patients' lives, there's something, isn't there, Alex, about students at all levels across the organisation at UWE Bristol on various programmes also been exposed to this sort of technology and science meets healthcare, and this is an important dimension for certainly UWE Bristol in terms of how we the mantra of solving real world problems and challenges and bringing together the subject expertise, and not just from Alex's kind of journey as he's described, but also in terms of the infrastructure and what happens within the university itself with other people and our technicians and wider support colleagues as well. So it's just fantastic as an ecosystem. So how do you envisage, Alex, the 3D printed food transforming the lives of those with dysphagia, both in terms of health outcomes and quality of life? And how does your work address the gaps in current solutions that we know about?
Mm-hmm. This is a great question. For people with dysphagia, eating can be a significant challenge, as we have established, and most of them rely on blenderized food that in many cases or most cases lacks variety, and variety is very, very important for our food choices. It can lack in flavor. It definitely lacks in visual appeal, and again, visual appeal for the food we eat is very, very important. A lot of cases, the nutrient content is not what it's supposed to be, and there are cases that the food itself is not safe to eat. In general, with the conventional dysphagia-friendly food that's out there, the concept is that one size fits all, which should not be with food in terms of nutrition and in terms of enjoyment as well. So, as you said, Mark, there are definitely improvements in terms of health outcomes. We can, with this technology, with this approach, we can optimize nutrition. With the 3D printed meals, we are able to control the nutritional content of the food, so to make sure that people get the right amount of proteins, the right amount of fats, the right amount of antioxidants. And obviously, this is especially important for people with dysphagia, who in many cases do not receive adequate nutrition. So that's one thing positive thing in terms of health outcomes, but also very importantly, it can help with improving the safety of the food. Conventionally prepared dysphagia food, blenderized food, can vary a lot in texture and consistency, but these products that we are developing, the 3D printed meals, offer control, consistency, and viscosity, which mean that in this way we can ensure the safety of the food. And by doing that, we reduce the risk of choking and the risk of aspiration. Also, in terms of, you mentioned quality of life, this type of, we can make, by using technology, make food more visually appealing. One of the biggest complaints of people with dysphagia in terms of the available food for them is that the food doesn't look appealing. And if the food is not appealing, visually appetizing, people don't want to eat it. They describe it as dog food, as blobs of food on a plate. So with the 3D printing, we can create, as I mentioned before, natural food shapes or almost any other shape to make the food visually appealing. And the other thing that's very important in terms of quality of life is that people with dysphagia often feel excluded from social events, for example, going to a restaurant, eating food there, or visiting some friends, eating with them, because the food they eat looks different and tastes different, And maybe when you go to a restaurant, they don't have this available food, so they feel excluded. So by creating these meals, we give these people back some sense of normality.
It's a great point around the kind of social exclusion, actually, and I hadn't really thought about it that way until you just mentioned it, Alex, in terms of, someone who has dysphagia, just, how they may feel precluded from going out and having a meal with family or friends, or having a picnic, or, going to a social event. And it's a really important factor. And that could, potentially lead to, someone's well-being not being the best it could be, and other kind of challenges as well. So yeah, it's a really great point.
So one day, many years in the future, could we have like restaurants having this as a machine, as a not for everybody, but for people with particular needs?
Absolutely.
So they can kind of make it there and then, rather than kind of a cook chill process.
Or they purchase it already kind of pre-made, and as well.
Yeah.
But that's you, Peter, going back into your future gazing again, aren't you? In terms of, but that is a potential, isn't it?
Yeah.
Just imagine how restaurants are now much more kind of aware and widened to not just allergies and things, but the inclusion of palatable food that could be 3D printed to be dysphagia friendly. As well. I mean, I don't think that's far away, really, in terms of...
Sounds like it's around the corner.
Yeah, as well. So, Alex, what's been the most significant milestones, do you think, or achievements? And I know you've got lots, so don't be shy, all right, in your research to date?
Thanks for the question, Mark. In terms of this project, I would say the most significant milestone is that we were the first to create multi-ingredient meals that are not only nutritious, but at the same time are safe for people with dysphagia, which is a big challenge to tackle. And at the same time, they are able to be 3D printed. It's difficult to make suitable food for people with dysphagia. It's difficult to make multi-ingredient food products that can be 3D printed. It's difficult to make nutritious food that can be 3D printed. Imagine now if you have to meet all these challenges together. It's a huge technical challenge. But through a lot of work, a lot of R&D, a lot of research and development, we managed to do it. And now we have a platform available in the lab that can help us create new products.
That's fantastic. It's just amazing. Again, it's a whole ecosystem of just parts coming together to find solutions for patients. It's brilliant.
Tell us a bit more about the specific challenges, because you said it's an enormous job pulling together all of these things, but what particularly have you found really hard that you've had to overcome?
Well, when you're trying something new, it's inevitable you're going to have challenges, there's no doubt about it. There were quite a few technical challenges. For example, I mentioned before the food hydrocolloids, these natural additives that we add to the food, so identifying the right ones in the right concentrations, in the right combinations, it required a lot of experimentation, a lot of R&D, a lot of research and development. Also, conducting this in-depth characterization of the food ink to make sure it has the right rheological properties, the right viscosity, the right texture, also required a lot of time and to develop a lot of expertise utilizing these high-tech instruments that we have in the lab. But over the years, I have found that overcoming challenges of this nature, technical nature, or any other challenges, the important thing is to try to think out of the box. And that can be very difficult to do because as scientists we're trying to think in a specific way. And the other thing that I have found very, very helpful is bringing people together with complementary expertise and giving them the space, the resources, and the time to tackle the different challenges. So that's what I try to do with this project, create a multidisciplinary team, embrace the different perspectives that the different people bring in the project. And also I found that it's very important to be open to unconventional ideas because these unconventional ideas can lead to breakthroughs. So this mentality has helped us a lot to push forward and to tackle technical challenges and other type of challenges.
So quite a few challenges. During your occasional dark moments, which I know any researcher or any founder of a company or anybody in these situations will feel, what keeps you motivated? What gets you going? What keeps you going when things get difficult?
No, that's a great question, because as you said, there are a lot of challenges, a lot of dark times. What drives me the most is knowing that this type of work has potential to make a difference in people's life. And over the last few months, after this work has gained some visibility, I have been contacted personally and through the university by people with dysphagia or their families, and they told us how interested or how willing they would be to take part in trials to test these foods, and also how important for them is to have a proper solution out there for them to use. But as we discussed, food is not only about nutrition, it's a part of our social connection or of overall well-being. So for individuals with dysphagia, the loss of joy from the food they eat can be isolating, as we discussed, and frustrating. So when with this approach, we give people back some sense of enjoyment, which I think is also I believe is very motivating for me. And also beyond dysphagia, I do believe that this technology, this approach we are utilizing can benefit consumers, industry, beyond dysphagia, because it can help tackle other important issues like personalized nutrition or the sustainability of the agri-food chain.
So some people are intolerant to gluten, for example. Could you kind of like program your printer to make gluten-free food? And other sorts of intolerances? Could it go down that route?
Absolutely, it could. It would require a lot of research and development to develop the specific food product, but yes, this would be definitely a possibility.
Yeah, it's just amazing. I mean, the possibilities are quite endless, really, aren't they, as well? So, come on, tell us about the collaborative efforts involved in this project, Alex, both within UWE Bristol and some of your amazing international partners that you and I have spoken about before.
As I mentioned, this is a multidisciplinary project, so I wanted to bring on board people with different ideas, with different expertise to try to tackle this problem. I have collaborators here at UWE, a collaborator, Dr. Sui Su from the School of Engineering, is part of the project. Also we have, as you mentioned, Marc, international collaborators from the University of the Peloponnese in Greece, clinical nutritionists, from the University of Novi Sad in Serbia, food scientists, and this is an ongoing endeavor. We want to expand it as much as possible, so we're bringing new people at the moment, new collaborators to help us with specific aspects of the project. So at the moment, collaborating with the University of Huddersfield, and also the Bristol Business School here at UWE with Professor Wendy Phillips to try to identify and capture the potential of this technology in terms of sustainability.
Oh, it's just amazing, yeah. And again, it just typifies, I think, what the ICA or the Integrated Care Academy is about, Peter, in terms of bringing together different parts of the university and beyond to find solutions for real-world challenges. And, Alex has mentioned several there internally that are working with him and supporting as well. It's just fantastic. So what's the next steps in your research, Alex? Are there plans for clinical trials or some kind of commercialization of the 3D printed meals? What's kind of like next on the horizon?
We do believe there is a lot of potential in this approach, so we definitely have more plans. So one of the first things we want to do is do a human trial, bring people in with dysphagia, and test the acceptability of these meals that we are producing, assess swallowing effort, satisfaction, digestive comfort, and really get what they think and incorporate their feedback into the existing products or new products that we want to make. And as I mentioned, food, having choice in the food you eat is very, very important. So we want to develop even more products because preferences in terms of food vary extensively. It can vary based on personal preferences, it can vary based on cultural or religious or your religion. So having a wide selection of suitable foods for people with dysphagia, I believe, is very key. So to produce these new types of meals, we do need a lot of R&D, but this is something we're already working on.
Yeah, and I think we've often talked about before patients with metabolic conditions, haven't we? Like diabetes, for example, where there could be some adjustments to some of the factors to make it applicable for them as well. And some patients may have coexisting kind of challenges, or so they might have dysphagia and be diabetic. So it's about how you could make the technology helpful for them as well. So yeah, it's just fantastic.
Very exciting. Looking way into the future, what kind of other innovations or advancements do you think could be happening in 3D printed food, whether in the medical application or indeed any other application?
This is a great question, and I do believe there is huge potential in terms of this technology. So sky is the limit. I think something that would be really interesting, fascinating, and very helpful would be real-time nutrient adjustment. So imagine having a printer that can adjust the nutrient content of the meal you're going to eat, in terms of proteins, fats, based on your physical activity on the day, or maybe even your blood sugar readings on the day. I think that would make a big difference in terms of personalized nutrition. And as Marc mentioned, expanding to other medical conditions, people that have cancer often undergo chemotherapy, and chemotherapy can affect the perception of taste. Potentially, we could create food that are suitable for them to make them appetizing. Or you mentioned diabetes, Marc, that's very, very interesting. Imagine having a printer that can print with precise control of macronutrients, have controlled carb meals. I think that would be a game changer.
Unbelievable.
I'm thinking of like in the sort of performance athletics world as well, where so much is about absolute perfect nutrition to match the exercise and the training. You can imagine an application there, couldn't you?
Yes, and so I think it's also seen beyond what we've been talking about today in terms of dysphagia, but also taken into a different space of sport, athletics, performance as well. I think, again, it's endless. So that all sounds so exciting, Alex, and it actually sounds that you and your team are at the beginning of a journey, I think, in terms of, and you mentioned the potential of human trials, you mentioned the potential of greater collaboration, and we just really wish you all the best, and the fact that it brings real hope to those with dysphagia for all the reasons that you've kind of outlined today in this podcast episode. It's just brilliant. Well done. Seriously, congratulations to you and your team. It looks like we're out of time, I think, just about. We could go on for much longer, couldn't we, Peter? This is such an interesting space to be talking about. Thank you so much, Alex, for taking the time to tell us about your brilliant work. I'm sure that our listeners will find this a really, really helpful and interesting podcast episode. We will put some links in the episode descriptor, and I mentioned the video that we have, which is a UE video, but also a few other links to maybe some of your work that you've done as well, and publications as well. It's really important that we put that in with the episode today as well.
Thank you very much. It's been a real pleasure being with you.
Oh, wonderful. And to our listeners, thank you so much for joining us. I really hope that you found it as interesting as we did. We could have kept on going for a long time. We just got going. So don't forget to subscribe to Let's Talk Health and Care for more episodes via the SoundCloud platform, and also Spotify for the latest in health and care innovation. And who have we got next time, Marc?
Well, next time, Peter, we've got Professor Anniko Varadi, who is a professor in biomedical research and is the director for the Centre of Biomedical Research here at UE Bristol. Anniko will be discussing genomics education for nurses and how the use of AI, generative AI and otherwise, is helping with decision-making and practice provision.
Well, that sounds fascinating, and I guess I thought it was only a matter of time before we have a podcast on AI. I don't know how we managed to avoid it so far. So really, really looking forward to seeing and speaking to Anniko in a few weeks' time.
And until then, well, it's goodbye from me, Mark Griffiths.
And from me, Peter Brindle. Stay healthy and take care.